Welcome, everybody. This week's DevHeads Office Hours Meetup. I'm happy to have everybody here. I am Brandon, and I've been a tech journalist for quite some time, and I'm excited to be building this community with some of the folks on this stream and all of you who are out there in the Discord server. We do this every week, so our agenda is obviously the introductions, which we'll get to in a second. Oh, I forgot to update this. This is now Ohm's Law. The foundation of everything, which is going to be presented by Petr Dvorak, who is on screen here with us. After that, we'll take some questions from the community and then talk about what we can do to get 1% better by next week. And then anything that you need from the community, asks and gets, and then design tips and resources. So I already mentioned a little bit about who I am. Why don't we start with the introduction of yourself, Petr? Go ahead.
Thank you. I'm Petr Dvorak from the Czech Republic. I work as a freelancing hardware design engineer, offering design services to customers from around the world. Thank you.
Umesh, you want to go?
Yeah, hi everyone. This is Umesh Lokhande, based from Pune, India, and I've been practicing embedded software and hardware past 10 years. I've been a consultant with many companies. So that's just a short introduction. Yeah, thank you.
Cool. Navadeep, your turn.
Yep. Hi everyone. I'm an electronic designer from Bangalore.
Cool. All right. So let's jump right into it. So basically, if you're designing hardware at all, you're familiar with Ohm's Law, but there's always a good idea to brush up on the basics and make sure you understand how things work and the best ways to apply it. And in order to get us through some of those lessons, we've asked Petr, who's one of our experts in the hardware design arena, to give us a little bit of a presentation today. So this is some good foundational stuff. And then after that, any questions that we get from the audience, we can go through and have an open discussion. So Petr, do you want to take it away? I'll disable my screen share and let you take over.
Thank you. Thank you for the introduction. So you should see my screen now with the Ohm's Law in the middle.
Yep.
Okay, so I prepared a few basic examples. As you said, it's a foundation of the electronics, electricity, one of the basic law of physics. And yeah, to brush some basics, never mind. Yeah.
Never hurt.
So never hurt, exactly. So here is the very basic situation, and there is a voltage source and the resistance represented by a resistor symbol. There is a current flowing through the circuit, and there is a voltage drop at the resistor. In the simplest case, the voltage drop at the resistor equals the voltage at the power supply. The voltage, the resistance equals voltage divided by current, which is the actual Ohm's law. There are some other versions. When you use simple math, you can change position of the symbols, like current equals voltage divided by resistance, or voltage equals resistance multiplied by current. When you use another small like equation from the physics, you can calculate the power at resistor, which is voltage multiplied by current, or voltage squared divided by resistance, or resistance multiplied by current squared. That's all you need to know for almost everything in the electronics. I have studied, or I studied a lot of like high-level mathematics at university, but I haven't used that stuff since my graduation. So, but Ohm's law I used every single day, like 100 times. So, stage 1, resistor for LED. Very common thing. We all started with some LEDs, some blinking, some lights, some bulbs. So let's say we have power voltage source of 3.3 volts, which is the common voltage of today's electronics, microcontrollers, Raspberry, Arduino, something like this. We have a resistor in series with LED. We can find in the data sheet of the LED that the forward voltage of the LED is, for instance, 1.8 volt at the current 25 milliamps. It means that, for instance, we can drive the LED to 25 milliamps, which is the value from the data sheet. In my opinion, it's too high current, but most of the data sheets use 25 or 20 milliamps, so I will stick with that number. And once you know what you do, you can lower the current as you want. So the simple circuit contains the resistor in series with LED, as I said. When the voltage drop at LED is 1.8 volt, and the sum of the voltage drops at resistor at LED is 3.3, it means that the voltage drop at a resistor must be 3.3 minus forward voltage on the LED, which in that case is 3.3 minus 1.8, which is 1.5 volts. Now you can use, or you must use the Ohm's law, which says that resistance equals to voltage divided by current. We have the voltage drop at the resistor, which is 1.5 volts. We can divide it, or we have to divide it with the 25 milliamps, and it gives us the 60 ohm as a resistance of the resistor. So if we want to drive LED with current 25 milliamps, you need to use a serial resistor with the resistance value of 60 ohm. Now the question is, what is the dissipation power on the resistor? Because it's a quite important thing. When you design a PCB, you must use not only the resistor symbol, but the physical device. And usually, or these days, the SMT technology is very common, and those resistors can be very small. And we need to know how much power the resistor can dissipate. So we can use the second equation from the first screen for the power. And it says that the power at resistance is equal to voltage times current, or voltage square divided by resistance, or resistance multiplied by current squared. Either format you use, you can get 37.5 milliwatts, which is in that case the dissipation power of the resistor in our simple circuit. Another question: what resistor size can be used for this dissipation power of 37.5? I copied the table from some catalog. I don't know if the screen is correct or not, but half of that is green, but never mind. And there is a typical power of each resistor size. We have 37.5 milliwatts. So you can see that even the smallest 0201 has the maximal dissipation power of 50 milliwatts. So it's okay. We can use almost every size available. The most common are 0603, which has 100 milliwatts, or 0805, which has 125 milliwatts. Another question. What if the voltage at the power supply is 24 volts, which is another common voltage level in electronics most of the time in industry? Let's see. In that case, as I said, the voltage at the power supply is 24. We need to drive the LED with the exact same current as before, so 25 milliamps. So the voltage drop at the resistor is now different. Now is 25 minus 4 watt voltage at the LED, which is 1.8, and it gives us a value 22.2 volts. This is our new voltage drop at the resistance. The resistor, from the Ohm's law, the resistance value is voltage divided by current. 22.2 divided by 25 milliamps gives us the 888 ohms. The nearest higher value is 910. So we have a new resistor for that circuit. What is the dissipation power again on the resistor? The very same calculation gives us 0.54 watts, so more than half of the watt, which is quite a lot of power. What resistor size can be used? Let's see. Back to the table. Here, 0.5 watts. We can see that quite big resistor size 1206 has the dissipation power only 250 milliwatts, and we have 540. So we need to use either 1812 or to divide the resistor into like more pieces. Let's say 3 resistors of 300 ohms would do the trick, and the maximal dissipation power would be then 3 times 250. It means 750. So a complete different situation. In the previous example, the size was 0201, which is resistor length of 0.6 times 0.3, very small. And now we need to use 3 pieces of 3.2 millimeter times 1.6 millimeter size resistor. So complete different situation. Voltage divider is another section. Yeah, like I think the second most useful thing you need to maintain for electronic design. The situation is very similar, but the LED was replaced by the resistor. We have power supply as before, resistor 1 with the reference R1, and the second resistor with reference R2. Now the voltage at the power supply divides in 2 elements, 2 halves, but the 2 parts. One is the voltage drop at the R1. I will call it UR1, and the voltage drop at the R2. I will call it UR2. Let's get together everything we know. We know that voltage means current multiplied by resistance. Current is voltage divided by resistance. And in our case, the total resistance is sum of 2 resistors. So the total R, the total resistance, is sum of R1 and R2. Now, we can use again the Ohm's law, which says that the voltage is current times resistance. I replaced the simple R with the sum of R1 and R2. And once we process the multiplication in the equation, we can get that the voltage drop at the resistor R1 is current I times R1, and the voltage drop at the second resistor R2 is current times R2. Very simple, nothing surprising. The current, again from the Ohm's law, is voltage divided by resistance. Our resistance is sum of R1 and R2. So let's use the general sum R1 plus R2 and replace the I in the previous two equations with the U slash R1 plus R2. And we can get very familiar equation for voltage divider, which is U R1 equals to voltage times R1 slash the sum of the resistors, or U R2 is the total voltage U times R2 divided by the sum of the resistance. This is what we all know, like we have that equation in the top of our brains, or we should. I think we should. Third stage and the last stage is I call it broken logic gate. It's like a story from the engineering praxis. And what's happened? I will tell you the story. There is a logical gate. It doesn't depend which logic function there is. Let's say it's like or and something. It doesn't depend. The voltage, the power supply voltage is 3.3, and there is simple Y port, which is output of the logic gate. We load the output of the logic gate with the resistor with the resistance of 60 ohms, and we measured that at the output of the gate, the output voltage at the output of the gate is 1.8 volts. What does it mean? Why the output voltage of the logic gate is only 1.8 volts? The gate is broken. We must replace it. It's something strange happens. Let's see what happens. Let's see what happens using the Ohm's law. Ohm's law tells us that current means voltage divided by resistance. We measured that the output voltage at the output of the logic gate is 1.8, and we know that we loaded the output of the logic gate with the resistor with the value 60 ohms. So 1.8 divided by 60 is 30 milliamps. This is the current flowing from the output of the logic gate. When we check the datasheet of the logic gate, we can find that output DC resistance of logic CMOS gate is in the range of 30 and 150 ohms. So you have to imagine that there is like DC resistance between the power supply voltage and the output of the logic gate. Physically, it's not a resistor. It's a upper side of the CMOS cell, but in a DC approach, the logic gate acts as a resistor. So now you can see that the entire circuit acts like voltage divider. So we know that the output voltage of on the output of the logic gate is 1.8. The total voltage is 3.3. So the voltage drop at the upper CMOS transistor must be 3.3 minus 1.8, which is 1.5. So we have a voltage drop at the upper side of the CMOS cell. Now we can calculate the resistance of that imaginary resistor. This is 1.5 divided by 30 milliamps, which is current flowing from the output of the logic gate. And by simple division, we can get the value of 50 ohms. you can see that the output value is perfectly within the range given or written in the datasheet. And the conclusion is the gate is not broken. We just overloaded it. We put it with too much resistance into the forbidden band because the allowed band of high voltage at the logic gate is 1.7, between 1.7 and the voltage equal as a power supply. So we need to replace the resistor with higher value to not overload it and to use it in the recommended and required condition. And that's it. That's the Ohm's law.
Thanks, Professor Dvorak.
I'm not professor. Thank you for your time.
So that was awesome stuff. I love the catch up, and then we've got some questions over here coming in. I'm monitoring a couple different places, so forgive me if I have a little bit of a lag. Navdeep, you asked, should you always drive LEDs at the rated current? That's a good question.
No, definitely not. The LEDs are designed for much higher current than we need to use. Let's say, as I mentioned in the presentation, the datasheet always use values like 20, 25, which is almost maximal current of the used LED. In my experience, or in experience of all engineers using LEDs, means that or it gives us the experience that the current in the range of 1 milliamp or between 1 and 5 is completely enough for very visible light of LEDs, and we save a lot of power, and we save battery lifetime and everything. So I recommend to start with 1 milliamp, very conservative value, to check it in the actual circuit, and then make some adjustments. But don't go crazy. I recommend start with 1 milliamp and make an adjustment.
That's awesome. There's another question here about whether it's always practical to use the values from calculations, versus, practical use versus theoretical use. I think that's the question here.
It depends on your approach. For the first thing, you can calculate using the equations, and when you know what you are doing, you can use your values based on your experience. But I don't know if I understand the question.
Yeah, exactly. It's at how much for you, for example. So you're experienced. Do you lean heavily on the calculation, on the value that's produced by the calculation, or is it okay to just lean on your past experience and say, yeah, it doesn't need to stick to that so much?
Now I understand better. When I designed the circuits for my customers, I always calculate the similar things as in the presentation, because to be 100% sure and to double check and triple check everything. When I play with electronics in my lab and tinkering and playing around, I just use 1 kilo ohm for the resistor and 5 kilo ohms or 10 kilo ohms. I don't look for 910 or 850. I use 1 kilo, 5 kilo, 3 kilo, 3 or something. But for the customer's design, I need to be 100% sure that I didn't make any mistake. So I verify all the values. Yeah.
Go for it, Trisha.
So, Navdeep, on that LED. So the thing is, like IR LEDs have lot higher like forward current actually. So in the ranges of 50 milliamps to 100 milliamps. So at that time, you need to recalculate your resistor for that value. Maybe like your application requires a high intensity of your this one LED, IR LED. So at that time, you will have a higher current requirement at that time.
Yeah, once your LED needs more current, you should use the value of the resistor coming from the Ohm's law. Sometimes you don't need a resistor at all. For instance, when we are speaking about the blue LEDs, the voltage drop at blue LEDs is most of the time more than 3 volts. And when you drive the blue LEDs from 3.3, you literally don't use any resistor. But I always place at least 0 ohm resistor placer on the board, because it gives you the freedom to change it and to use at least 1 ohm, 3.3 ohm, 10 ohms in the real device. Because once you don't use the footprint, or you don't place the footprint on the PCB, you can't use without scratching the PCBs and a lot of manual work. So I recommend to placing every time the so-called footprint placer, and yeah, to calculate everything according to Ohm's law, because it never fails.
Never lets you down. Trisha.
Got it. No.
Sorry, did you have something to say, Navdeep?
Oh, no, just telling. Got it. Yeah, thanks. Thanks for the input.
So Trisha, Petr works for clients, making sure that their designs are hit spec. You aren't a freelancer, right? So a lot of your work has been for a company. How, are you as precise as Petr is, or do you sort of just say, I can sort of waver from the calculations of Ohm's law and, just get the job done?
So it depends actually. For example, in before, when we used to get normal dip LEDs, like through-hole LEDs, they used to be very low intensity, like the illumination was very low. At that time, you needed the rated values, like higher, like very low values actually. But nowadays, the LED technology has gotten very good, and even in 1 milliamps, 2 milliamps, it's very bright. So for indication purposes, you need even go higher values actually. So that's why most of the time for illumination, indication and all, I go with depends as well, because inventory. So another thing is inventory. What inventory do you have? So some of the, you can calculate it based on the Ohm's law, but still do you want to go with that precise value, or you want to go with the one which you have it in your inventory? So most of the time it boils down to that as well. So you always have 1K, 10K, anything between 4.7K, those kind of values, but very strange values which you get from Ohm's law, you might not have. So it's like a what do you say, it's not an exact thing which is required, but you can go with a near about value as well. But yeah, so I do go with the forward voltage. So I take into consideration, because red has very lower considered to blue. Even the green nowadays are coming with almost, I think it's blue ranges, I think. So you need to take into consideration. Otherwise, what will happen is you have multiple indicator LEDs. What will happen is some of them are brighter and some of them are very not bright at all. So you will have mismatch of these LEDs. So you need sometimes similar value, you need to calculate, okay, this is the forward voltage of this red LED. Okay, I need to go with the higher value for this or lower value for this. So sometimes you need to match the intensity of all the these LEDs. So at that time you will need Ohm's law to calculate. Yeah, so to get the near about value, I would say.
Yeah, a good point. You touched a good point. For the simple signalization, I would definitely use 1K. I calculated 888. I used the nearest higher value, 910. But for the simple signalization, I would use 1K. But for instance, 1 month ago, I finished a design for a customer from Germany. That guy is very accurate, very strict, and he wants the current through the LEDs is exactly 1 milliamp. So I needed to use the exact value. So it depends, yeah. As I said.
Exactly 1 milliamp.
Yeah.
I think the battery application or low power application would require exact current. They would decide this beforehand, when they were deciding the power into consideration in their project. They would decide this power for this indication LEDs as well. So I think that's why the client would have accurate current requirement at that time.
Yeah. For the simplicity in the presentation, I used the datasheet value of voltage drop at the LEDs at the given current. because it's a voltage drop at the given current. Once we use 1 milliamp, I can't use 1.8 because the voltage drop would be lower. So in the once I need to be 100% accurate for the customer from Germany, I need to take the particular LED, to buy the sample, to use it, to connect it to the power supply, and to measure the actual current voltage drop at the given current, in that case 1 milliamp. And then I can get back to the Ohm's law and recalculate, and I would get, for instance, value of 3K3 or 2K7, something like that. So yeah, the LED example was used for the pure simplicity, but once you go deeper and deeper, you can get surprising conclusions.
Yeah.
What is the color code chart that you all use? Because I always get confused for resistors, right? I always get confused of, which is which, and, when you have the sequences, what they mean. What references do you all use?
Do you mean the THT resistors?
Yeah.
With the color code?
Yep.
Yeah. You would be surprised. There were times I remembered all the color codes. Like I can't be wrong, but I think 0 is black and 1 is I don't even know yet, because I have been using only SMTs, and one thing I do. Of course, I have a lot of THT resistors for the breadboards and everything. Once I need to check the circuits before I go to the PCB CAD, and every time I take the THT resistor from the back, I switch on my multimeter and verify the resistance. Why? There are bags with the values written on it, but I'm not sure if I placed the correct resistor into the bag. So to verify, to measure the resistor value, it takes like 10 seconds, and I can be sure that there is no problem in the circuit in the resistor value. Once I blindly remove or take out one resistor from the bag and place it into the breadboard, and the circuit doesn't work, I need to get back and verify everything. So I need to be sure. I need to save time. I don't want to make useless movements. Yeah. So this is my strategy.
Well, that, and I mean, somebody had a question about this in the server a while ago, and I think my eyes are bad because I can't even tell the difference between the colors of some of these things. They're so close. So that's good practice.
Exactly. I always measured it. Always. There are THT resistors with written value, like the green ones, or in my country, in my segment of industry, because I think it depends between the nations and producers and manufacturers. So my advice is measure it, because it saves you time and everything.
That's awesome. So Sriksha, how about you? Do you remember all the color codes, or is there a place that you go to look them up, a reference?
Most common ones I remember, but the things in middle I don't remember, like the violet and like the gray ones. So I think gray is 9, I think, but I'm still not sure. The common ones I do remember. Yeah. So yeah, but we can nowadays it's always you can search it up, so it's not a big deal. And through hole resistors are very rare these days. You use it only on breadboarding and stuff. And so SMT has replaced most of the designs. So yeah. In SMT, you cannot, there is no color code, and even the smaller ones, they don't even put the values on them, actually. So it's so no use there as actually color code. Yeah.
Great. So Navdeep has got a question over here. Why don't you just go ahead and ask it, Navdeep?
Oh, not a question. I just looking. So in the environment application I was using last week, right? lowest forward current was 2 milliamps. So we're trying to figure out like having the lowest power one and stuff like that. So is there anything better than that, or did anyone discover what is your least benchmark, the forward current of any LED? Probably it would be in red, but yeah.
Anything with a low forward current, I don't know. I think we'll, unless any of you guys have seen anything off the top of your head, I think we'll drop it in the server and see if anybody's got anything that they could put forward. All right. Well, any other questions, guys? Anybody have anything they want to add on this topic? Thanks so much, Petr. This is great. This was a lot of fun too.
Thank you. It was fun to get back to the basics and to say about it.
Also, guys, like so the Ohm's law applies on AC as well. So there is like the entire different topic comes up there. But yeah, so the Ohm's law in AC is the similar if it's just resistance, but there is also capacitance and inductance comes into picture in AC. So that would be a different thing. Yeah. So addition to this, but yes. Yeah,
we definitely that might be a good follow on for us to explore at some point. Yeah, that's a really good point. Hey Syed, how you doing? Okay, well, I've been
like looks like I joined the party late, sorry. So I'm trying to catch up from the couple of past events, but I couldn't be able to match the times today. I kept an alarm, but still it went off. So I'm just listening from few minutes. Yeah.
Well, welcome. If you have any questions about Ohm's law, that's what we're on right now. So you got the panel here to help. All right. Well, thanks, Petr. That was awesome stuff, and thanks for your inputs too, Shrisha. I'm gonna recommandeer the screen. Oh, Petr, what are your feelings about your slides? Do you think you could post those in the server, the slides you had?
Sure. Why not? So in the post on the server, like where do you want me to place the slides?
I'll put a discussion thread. I'll put a discussion thread up, and then I'll send you the link to the discussion thread.
Perfect. I will place it there.
Great, awesome. Okay.
I think Umesh had something to add. I think is it?
Not really, nothing substantial, but yeah, I mean, always it's a good practice. My recommendation is to have the multimeter and check it. Don't Google search it, because there are a lot of fake images and people, those who are very beginners. Like I have hired a guy, I think month or 2 months back, and I asked him like what this value is. He was searching online and trying to match with the images, and a lot of images are wrong online. So not to do that. And now remembering those formulas and all those things just doesn't make sense. Just take a calculator, calculate it, and then use it. Another thing I want to add is how I personally use it. I definitely always do the calculations just to safeguard myself. And then I choose the value which is nearby available into the market. So I at least know that these lines I should not cross in terms of the values of the components. So, I mean, whether you follow those numbers critically, like if you're building a product which is very precise or precision control or something, let's say you're working with some FPGA design on power optimization, you have to be highly accurate there. There's no chance. Otherwise, some components you will fry anyways. So my personal opinion is you can always safeguard yourself by having real theoretical calculation. So theoretical calculation doesn't mean the practical accurateness. Like you can have a practical accurateness based on maybe your experience might tell you better, because how the component functions in certain situation, that's really depends on so many factors, as Peter also added, like the material of PCB and all those things comes in. So I think that is what I wanted to add. Nothing special, but thank you very much, Peter. It's really a time where we have to ask this critical question when you were explaining how been so far we came, because we learned these concepts in the schools, and now we see we're still using it. I mean, the moment that Brandon set up this topic, I was keep asking myself like how significant it is that it stays with us, and maybe it will stay till we die and design circuits. Yeah, thank you.
Awesome. Well, thanks so much. All right. So that's great. We got a few questions in the server that could use some answering. Flo had a question around STM32 firmware extraction, and then there's another one around understanding annotation in Altium. I think I might point that one over to Plav. And then Chimmy has some guidelines for selecting an MCU for a battery-powered device. We had a discussion going around that, a lot around deep sleep states and other things. But if you have answers to some of these, or you're interested in joining the discussion, jump into the server, and I will post this into the office hours discussion thread, like I said, so you can answer them as you wish. Okay, so coming up, so the next office hours, we're going to have a discussion. It's going to be an open forum around if you have to pick a programming language, what should you pick? C, Python. We've got a couple of people in the server who are exploring the world of Rust. There are a lot of options out there today. What should you pick? I have some ideas around what the general consensus will be, but you never know. A lot of C programmers, obviously. DevHeads demos coming up. Next week is Srisha on analog circuit design basics, and then also using LT Spice. So that was a fun one that we recorded just a little while ago. And then the next one during the week of Embedded World is going to be Navadeep and integrating peripherals into FPGA-based designs. So that's fun. Then build custom packages and C programming fundamentals are further down the pike. Earlier this week, we launched one on the DevHeads YouTube channel about MQTT topic structures with Lucas Malinowski. So he's using these Roblox environments, which are pretty fun, to explain the concepts, which is really good if you're a beginner to understand why and how you need to structure out your MQTT topics appropriately so you can scale in the future. Projects and partnerships. So engineering hours tutorial sessions, part 2. We had an awesome one on Sunday, and we've got another great one lined up this Sunday. So Umesh is taking us through various topics, how to essentially build end-to-end IoT designs and giving us live demonstrations of those. Umesh, do you want to speak a little bit about what you're going to be talking about this coming Sunday?
Yeah, so before that, I want to add one funny part, because last engineering hours, you have seen I was in my office and I couldn't able to find through whole resistor of 1K because in my entire working, I just use SMD components for production. So all the through all components is in my home lab. So this happens right now with everyone. And, for LED to protect, you probably practically just need 125 ohm or something, wherein we always with the habit puts 1 kilo ohm resistor because that's very easily found in a through hole. So just wanted to share. And if you're lazy like me, super lazy person, I don't care controllers and put straight away. I have to be practically correct sometimes, theoretically correct sometimes if I shoot something, so people should not come back to me. But anyways, I want to talk about this weekend's engineering hours, and I will take you through the Node-RED, the application of Node-RED, and I will be showing on the Raspberry Pi how you can use Node-RED, which is awesome tool. You don't need to write a script like a JavaScript or Node.js scripts, and still through the wiring or visual programming, you can not only control the hardware, but you can also create the front-end UI application. So it's like I will be showing how to install Node-RED on to the Raspberry Pi, and then I will show you how you can control and monitor the data using the Node-RED. So it's like showing both aspects, how you can deal with the hardware using Node-RED, at the same time how you can use the same Node-RED and solve the problems related to the dashboard and front end that you wish to create for your IoT application. So it would be amazing. I mean, if anybody is interested to know, and Node-RED is pretty popular. I mean, this week itself, you might have heard the Blink has added support for MQTT protocol, and in their post, they have written why they needed MQTT, because they wanted to let the other platforms to talk to their platforms. And Node-RED was one of a listed framework that they, I mean, the reason why they are doing, because customers are asking, right? Otherwise, why would commercial platform and commercial developer would waste their time? So I think it would be amazing. And even for people who are freelancing and the contract developers, I think it's a great tool to learn to show a beautiful outcome of your prototype to your customers. Because sometimes we can't afford to learn this Java and use Android Studio and learn JavaScript. We don't have that much time. And I think I personally believe maybe someday we'll talk about this. Why? What is the role of zero code or low code platforms? Because many times as soon as you speak out this, people thinks it's something that try to replace the programming languages. No, it's not like that. But there are certain things can be done, and it would be amazing to if anybody have any interest in IoT application development on the hardware side or on a front end side, then it would be amazing to learn in engineering hours. Thank you.
Thanks a lot. Yeah, I'm looking forward to it again. So you can join that. That's actually exclusive to the DevHeads Discord server. So you go to discord.gg/devheads and you can jump in and then attend that in server. So that's happening Sunday. Of course, Sunday's Easter. So, join after you get out of church or whatever. All right. So any proposals for the community? Does anybody need anything or want anything, or are we missing something? And how could we get better by 1% next week up to 172%? Nope. Okay, great. Just monitoring over on the other channels now. I didn't realize that I exponentially increased what I would have to do by adding these streams, but it's cool. All right. If you have any suggestions or thoughts, ways that we can keep improving, feel free to reach out to me. I'm Brandon Lewis. You can find me on LinkedIn, in the server at TechieLou. This isn't mine or, Umesh's or Petr's. This is all of our community. So we just want to keep getting better and learn and grow while we're doing it. Here are some resources that some of the dev heads have contributed. Recommendations for scopes and soldering guides and Navdeep's blog. So some good resources there. You can find them all in this PowerPoint when I upload it to the discussion thread. And other than that, that's it. So our next meeting is going to be on 4/5, Friday before at MetaWorld. And if there are any additional topic requests coming up, you can reach out to me or just post them in the dev chat. Thanks a lot. Appreciate everybody's time and participation.
Thank you. Have a nice
you.
weekend.
All right.
And happy
Thank
Easter
you.
to all of you. Have a great
Happy
time.
Easter.
Happy
Thanks.
weekend.
Yep.
We
See you
too
outside.
celebrate in India, by the way.
Yeah.
Yeah, we too have holiday. So
What holiday is it? Is it Easter, or are you talking? Is it something else?
Yeah, we
Good
have a
Friday.
Good Friday today,
Mhm.
and then we do have a Easter, but these days it's come as a Sunday, right? So
Mm-hmm.
working people would have the problem. They will lose
Yeah.
out of one holiday.
For sure. All right, guys. Well, we'll see you next week or
See
in
you.
engineering
Bye.
hours. All right. See ya.